Welcome to the Rule of Nines and Parkland Formula practice questions video. This video will help you learn how to calculate the total percentage of body surface area that was burned and how many milliliters of fluid we need to give our patient. I start by drawing this stick figure every time. Here's our first practice problem. Go ahead and pause the video and read the problem for yourself, and then I'll point out a few things to pay attention to. Hopefully you had a chance to read the problem. I start by drawing my stick figure every time. The head gets 4.5%. Each arm gets 4.5%. Each leg gets double the arms, so they get 9% each. The torso gets 18%, which is double what the legs got. And then the perineum, or the genital area, just gets 1%. The anterior head means just one side of the head, so 4.5% for the anterior head. By the way, did you notice, didn't even bother to mention 28 years old, male patient, none of that matters. Posterior left arm just means one side of the arm, so 4.5% for one side of the left arm. I missed a comma here, but it should say comma, posterior right arm, so 4.5% for the posterior of the right arm. Then the anterior trunk, so that just means one side of the trunk, so 18% for that. Next, the front of the left leg. Again, it doesn't matter which leg, no, just the front of one of the legs, so 9% for that. I do like to put point zeros, so you see me even that out there. And then the perineum is just 1%. So total this up, and that will provide your total body surface area that was burned. So that totaled 41.5% of total body surface area that was burned. So next you want to look at the weight, and notice that it is in pounds. The Parkland formula uses kilograms, so we need to convert from pounds to kilograms. A tip that one of my teachers always used to say is that Americans weigh more than Europeans, so therefore it's 2.2 pounds for every 1 kilogram. So one thing you want to check with your teacher on is whether they are going to want you to round your weights for this purposes to the hundredths, which is normal. In nursing dose calc, usually kilograms you would round to the hundredths, or at least go to the hundredths place. For my school purposes, we just rounded to the nearest whole number. Not sure why, but for our dose calc exam, it was the nearest whole number. So for the purposes of this video, I will be using 68 kilograms in the Parkland formula. The Parkland formula tells you how many milliliters to provide over 24 hours for your patient. You multiply 4 times the burn amount times their weight in kilograms. Now this part's really important. When giving these fluids, half of the total that you'll need to give is given over the first 8 hours of care. And the next half is given over the remaining 16 hours in the day for the total of 24 hours. So 8 plus 16 is 24. So once again, the total that you calculated above, the 11,288 milliliters, half of that will be given in the first 8 hours of patient care, and the remaining half will be given over 16 hours. So in our case, half of 11,288 is 5,644 milliliters. That's going to be given over 8 hours. So you would set your pump to 5,644 divided by 8, which in our case equals 705.5, and we know that we don't use point anything for milliliters per hour on pumps. So we're going to round to 706 milliliters per hour. And the remaining half will be delivered over 16 hours. So you will notice that this rate will be quite a bit slower. And it makes sense because we're giving the same amount of fluids, but we're giving it over double the time. So this is going to round to 353 milliliters per hour. Again, we don't use decimals in setting the pump in milliliters per hour. So let's put this all together and do another practice problem. And once again, go ahead and pause the video so you can read the entire problem. So go ahead and start by drawing your figure and labeling the maximum amount of burn surface area that each portion of the body can have. So it's the front of the right arm, only one side of an arm, so 4.5 for that. Next, we have the posterior torso, so only one side of the torso. So we have 18 for that, and you'll see that I do like to use a 0.0 to keep my decimals lined up. Next, we have the back of the left leg, so just one side of the leg. So we'll add 9.0 for that. And now we have the ventral side of the right leg. You'll notice words like ventral, back, posterior, anterior. They're all hints that you're just using one side of the body. So for the ventral side of the right leg, we will add another 9.0. And then we have the anterior of the head. So we're only going to use one side of the body for that, so it will be 4.5. So in this problem, we only used one side of the body. In the next problem, we will do a scenario where you have to double some of the measurements. So I'm going to add these up and be right back. That totaled 45% of the total body surface area as being burned. So that takes care of number one. Next, we need to figure out our patient weight in kilograms. That's easy, right? 143 divided by 2.2. And I made sure that we had an even number this time, so that worked out to be 65 kilograms. Next, let's do the total amount of lactated ringers to be given over 24 hours. And for that, we will use the Parkland formula. So remember, the Parkland formula is equal to 4 times the total body surface area that we calculated above times the weight in kilograms. And when you're multiplying the body surface area, you don't actually use 0.45, you just use the number 45, the whole number. So your total fluids that you need to provide over 24 hours is going to be a pretty large number in most scenarios. Next, let's determine the flow rate during the first 8 hours. So what will be our milliliters per hour that we will set our pump to? And then after that, we'll calculate the flow rate for the remaining portion of fluids over the final 16 hours. So all we have to do is divide 11,700 by 2 so that we get the first half of the milliliters that we are going to provide over 8 hours. And then we'll divide that number by 8 hours so that we know what to set our pump to in milliliters per hour for the first 8 hours. And remember, this number will be bigger, and the second part of the problem, the flow rate over the remaining 16 hours, will be smaller. So always make sure that that is what ultimately happened with your math, because that's a hint that you got it correct. And again, we don't use decimals on pumps, so this rounded to 731 milliliters per hour for the flow rate during the first 8 hours. For the purposes of time, I'm just going to speed up the remainder of this problem. Just check your math and make sure you got it correct. And here's our final practice problem. Go ahead and pause the video. This will be the most challenging one. So I've gone ahead and drawn my figure. So this says the front of the patient's right arm. So we will have 4.5 for the front of the arm. The ventral and dorsal part of the head, so both sides of the head. So we are going to put 4.5 for the ventral side and 4.5 for the dorsal side. Then it's the front and back of the left leg. So we have 9.0 for the front and 9.0 for the back. Her perineum, ouch, so 1.0 for that. And she burned her interior torso, only one side of the torso, so 18.0 for that. Go ahead and add that up. And then after that, we will convert the patient's weight from pounds to kilograms. For number 3, we will use the Parkland formula. And as you know, that is 4 times the body surface area we calculated above times the patient's weight in kilograms. And again, half of this total volume over the 24 hours will be given in the first 8 hours of patient care, and the remaining half of the fluid will be given over the last 16 hours of patient care. So you divide 13,130 by 2 to get half of it, then divide that by 8 hours so that you know what to set your pump at for milliliters per hour. I'll speed up part 5 here so you can see how I finish this problem. I hope this video on the rule of nines and the Parkland formula for burns helped you. If it did, please give it a thumbs up and good luck on your exam.